In this video, we're going to be taking derivatives that involve natural logs. We know that the derivative of natural log of x is 1 over x, but these derivatives are going to be more complicated than that, some of which are going to involve the chain rule. So if we were using the chain rule, we could rewrite this as take the derivative of natural log of u, in which case we would get 1 over u times u prime, where the argument to the log would be our inner function, and we get 1 over whatever that is, and then times its derivative. So let's do some examples. We want to find the derivative of y equals the natural log of 2x. So in this case, our inner function, or our u, is 2x, and its derivative would be 2. Then the derivative of my function is going to be 1 over whatever the argument of the log is. So 1 over u would be 1 over 2x in this case, times its derivative, which would be 2, which simplifies to give me just 1 over x, which happens to be the same thing as the derivative of natural log of x. Okay, let's look at y equals the natural log of x squared plus 1. In this problem, my inner function, or my u, is the argument to the log x squared plus 1, and its derivative would be 2x. So, the derivative of the outer function, natural log of u, just gives me 1 over u, which is x squared plus 1, times u prime, which is 2x, and I can write that a little neater as 2x over x squared plus 1. Okay, this problem, y equals x times natural log of x, is going to be a product rule, where my first function is x and my second function is natural log of x. Remember, the product rule states that the derivative is the derivative of the first function times the second, plus the first function times the derivative of the second one. So we are going to get y prime equals the derivative of the first function, derivative of x is just 1, times the second function, plus the first function, times the derivative of the second, derivative of natural log of x is 1 over x, and this simplifies to be natural log of x plus 1. Okay, here we have another chain rule problem. In this case, though, my inner function, my u, is natural log of x, and its derivative is 1 over x. My outer function is a u cubed, and its derivative would be 3u squared. So the derivative of my function is going to be 3 times u squared, and I'll put the u back in there, it's natural log of x, times u prime is 1 over x. And so I'll write that as 3 natural log of x squared all over x. Okay, for the examples that follow, we're going to need to remember the properties for expanding logs. They will make taking the derivatives much easier. Without expansion, they would be very difficult chain rule problems. But by expanding, we can simplify how we take the derivative greatly. So the first rule for expansion is the product rule. It states if I have the log of a product of two things, I can separate that into two logs separated by addition. For division, it separates into subtraction, and the power property states if there's an exponent on the argument to my log, I can write it in front of the log. So, whenever we're taking the derivative of a natural log, or any log for that matter, the first thing I want you to do is think, can I expand this problem? So let's rewrite y equals natural log of the square root of x as y equals the natural log of x plus 1 to the 1/2, so I can see the power there. And then the power property tells me I can bring that out front. So this is 1/2 times the natural log of x plus 1. Now it's become a simple chain rule problem. My inner function here is x plus 1, and its derivative is just 1. So the derivative of my entire function, 1/2, stays out front. The derivative of natural log of u is 1 over whatever u is, times the derivative of u. And so we just get 1 over 2 times x plus 1. Okay, in this problem, I see division, so I can turn it into subtraction. And I'm going to rewrite this as the natural log of 1 plus e to the x minus the natural log of 1 minus e to the x. So we're going to take the derivatives of each of these terms separately. For the first one, I have a chain rule where the inside function is 1 plus e to the x. Its derivative would just be e to the x. For the second term, we also have chain rule. The inside is 1 minus e to the x, and its derivative would just be negative e to the x. So, the derivative of my whole function, looking at the first term, we have natural log of u. I get 1 over u, which is 1 over 1 plus e to the x, times u prime, which is e to the x. For the second term in the function, I'm going to keep the minus here and say it's minus 1 over u is 1 over 1 minus e to the x, times u prime is negative e to the x, and then minus and negative will become a positive. This cleans up to be e to the x over 1 plus e to the x plus e to the x over 1 minus e to the x. Okay, again, I've got division going on. I can separate this into subtraction. This is natural log of 2x minus natural log of x plus 3. So for our first term here, this is actually the first example we did, our u would be 2x and its derivative would be 2. For our second term, our u is going to be x plus 3 and its derivative is just 1. So when we take the derivative of this, I get natural log of u gives me 1 over u, which is 2x in this case, times u prime, minus natural log of u gives me 1 over u, which is x plus 3, times u prime, which is 1. And so I get 1 over x minus 1 over x plus 3. Okay, this one, a little bit more complicated. Let's rewrite it so that I can see the power here is the natural log of x minus 2 over x plus 2, all being raised to a 1/3 power. So I can bring that exponent out front. And then I have division, so we can turn that into subtraction. So I have 1/3 natural log of x minus 2 minus 1/3 natural log of x plus 2. Okay, so I haven't taken a derivative yet. All I've done is rewrite my function. Now, if we look at each term separately, I see a pretty simple chain rule problem. Here, my inner function is x minus 2, its derivative is 1. And for my second term here, my inner function is x plus 2, and its derivative is 1. So, if I take the derivative of the first term here, 1/3 stays out front. Derivative of natural log of u is 1 over u, which is x minus 2 in this case, times u prime is 1. Then we keep the minus 1/3 for the second term. Derivative natural log of u is 1 over u, which is x plus 2, times u prime is 1. And we get 1 over 3 times x minus 2 minus 1 over 3 times x plus 2.